Hello, we are here for one more lesson of this T-FLEX analysis training course, and today we will talk about a new chapter, and this time is dedicated to buckling analysis, which is a new thing, and we've left the static behind. So buckling analysis, it's a new type of calculation of study we can do inside T-FLEX analysis. And I've opened one of the examples that came with a standard installation. This is basically a simple shape that is under a compressed and straight force. To explain a little about what is this topic of buckling, a couple of definitions and important definitions to understand this phenomenon. So equilibrium of a statically loaded structure is called stable if small disturbances cause also small deformations. There are cases that we call buckling, where we have this phenomenon of buckling when small disturbances that come from the forces that are applied to the system will cause large structural deformations, and these deformations exceed the framework of the linear theory of elasticity. These loads that cause this phenomenon buckling are called critical, and the respective states, we call them critical states. Under these compressing forces, even that they are not very significant, when they exceed the critical value, these additional bending stresses reach quite large values, and they could threaten the structural integrity of the system that we have. Therefore, this critical state, which immediately precedes the rupture, is considered inadmissible in real-life conditions because, as you might understand, this can threaten human life or can lead to big losses in terms of money because of the structures in the work and so on. So we have a lot of structures that we can study under this buckling. You can see a little also the videos that we are releasing for examples of this kind. But basically this buckling analysis module serves for conducting the so-called initial buckling structural study. The result of the study is a coefficient of the critical load under which the structure may change into a new equilibrium state, and the shape of the new equilibrium state corresponds to that load of this new state. In such a case, a situation it is possible that the critical load under buckling occurs and could be less than the load under which the maximum strength of the structure will be exceeded based on the linear static stressed state of the structures. In other words, the stresses in the structural material may not reach the ultimate values, but these deformations due to the buckling may cause the rupture in the system. We have a mathematical expression to define this. I think it's a theoretical side. It's not so important for understanding this buckling. But the idea it is to reach a value of the critical load under which the structure may be subjected to this buckling phenomenon, so that we can optimize the parts or the assembly in order to achieve a safe condition. And this is what we try to get in this buckling analysis module. So you can read a little more about it in our theoretical course. You can see also the examples that we have apart from the video lessons, and for sure any help or any other clarification that you may need about this topic, you can send us a contact and we will give you all the necessary support.